Hey dear viewers, we are here again to talk about chemical kinetics, another application where we are using computer simulation in Python language. So the scenario that we are having says that a research team is studying the interaction between penicillin P and beta-lactamase B, an enzyme produced by certain bacteria that inactivates penicillin. The reaction is modeled as P plus B, giving you an inactive complex. The rate law for this reaction is rate is equal to K times concentration of P times concentration of B. The team wants to understand how the concentration of penicillin and beta-lactamase affects the rate at which penicillin is inactivated. Given that the rate constant K for this reaction is 0.02 liters per mole per second, visualize how the rate of inactivation varies with the concentrations of both penicillin and beta-lactamase. So what is the reaction rate if the concentration of penicillin is 0.5 moles per liter and beta-lactamase is 0.3 moles per liter? And plot the reaction rate as a function of the concentrations of penicillin and beta-lactase. So to deal with this, we have to understand that this is penicillin, which is an antibiotic, is being acted upon by a beta-lactamase, which is a bacteria, an enzyme produced by certain bacteria, such as the Klebsiella. Then there is another one called E. coli. These produce such beta-lactamase, and the beta-lactamase invades penicillin by attaching themselves onto the beta-lactam ring of penicillin, thereby producing a hydrolyzed product, which is an inactive complex, and that is the useless penicillin, which cannot fight against the bacteria that are being targeted in the body. So what do? We are going to right away go to the simulation and then move and do the programming. So in Python, we have already created a template or a structure that we are going to be following. We are going to be following this structure to substitute in the values and actually modify the code to suit our purpose. We have done this to avoid wasting a lot of time. So we are going to import NumPy, which is the numerical Python for manipulating data in Python. Then we are going to also import the matplotlib.pyplot, which is very important for plotting. So this is going to be NP, and this is going to be PLT. So import matplotlib.pyplot as PLT. Then we need to define the function. The output of this function represents the rate of reaction, but they are the inputs or the independent variables that we need to substitute in here. So one of them is the concentration of P, which is the concentration of penicillin. Then we also have the concentration of beta-lactamase. And then the rate constant K. So once we are done with that, this function must return K times the concentration of P times the concentration of K. So what we are going to put here, we are going to multiply by the concentration of B, not K. So here is going to be the concentration of penicillin. Obviously, that is the model that we have, that one. K times the concentration of P times the concentration of beta. So from there, we shall initialize the values as we have been given, 0.02, then 0.5 for penicillin concentration, beta-lactamase concentration is 0.3. Then we are going to be looking at the rate, which represents the rate of the reaction that takes in the penicillin concentration and beta-lactamase concentration. That is what has been initialized. So we are going to also go ahead and use the printed format. That is by using the formatted string literal for Python, and if we want the plot, the print to be like the reaction, of course we want the string to be there, but holding also some value, which values could have been calculated by a given function. So we are going to do something with this formatted string literal, which helps to work, to manipulate the code as if we have a placeholder. So in these brackets, we have placeholders for the inputs. So the inputs here, we have the penicillin concentration, okay, the rate, we want it to be like the rate, the reaction rate for penicillin concentration equal to that, and beta-lactamase concentration equal to B, which is the beta-lactamase concentration that is initialized here, is, okay, so the answer is going to be put here, and it is going to be stored in the variable rate, which has been initialized here. Okay, so this function will calculate those values, and those values will give the value that is going to be placed here, and that will be the rate of the reaction. So let's look at rate of reaction for P and B. Range of concentrations for P and B. We are just going to use NP line space as a function to have values ranging from 0.01 to 1.0, and those are supposed to be 100 data points. For concentration of beta-lactamase as also 0.01 to 1.0, having also data points equivalent to 100. So we're going to also have a 2D plot, and which is taking in the values of P and B. So we're going to use a function mesh grid that is coming from NumPy library for us to be able to produce that 2D print that has, it is going to help us create a grid of concentrations. So these grids are obviously made by a mesh grid function. So now, when we are here, we are going to obviously put the concentration of P values, and we are also putting the concentration of B values. And from there, we are going to do the calculating the rate. So when we calculate the rate for the grid, in each of these grids that we have made here using mesh grid, we need to determine the values for rate of reaction. So rate of reaction by putting in these concentration values for P and B. So the function that we are going to be taking is obviously going to be rate of values. Rate of values will be the rate of reaction. The rate of reaction is the function that we created. So you have to be consistent, which is taking in P, B, and then K, which is the rate constant. Then we say the fig is obviously a command that creates a new figure for object. A new figure object for plotting. Then the fig size, it sets the size of the figure in inches, with the meaning that we have 10 width inches, 6 height, that is 6 inches. Then we also said that this command is going to be telling us that one means the number of rows. The first one means the number of rows in the subplot grid. Then the next one, the number of columns in the subplot grid. And then the last one indicates that this is a first subplot in the grid. Obviously, this 11 is specifying the subplot layer. So what else? The projection is equal to 3D is telling us that it indicates actually that the plot should be rendered in 3 dimensions. So the others is now labeling the axes. So labeling the axes here, we are talking about the labeling the y-axis. So the x-axis is labeled as concentration of penicillin, and then concentration of beta-lactamase is what we are going to put on the y-axis. So beta-lactamase. So the next one is Z label, which is the rate of reaction. And then the title, we are going to set it to be rate of penicillin inactivation versus the concentrations of penicillin and beta-lactamase. So what happens when we save and then run this program? So this word penicillin is not defined. That was an error. So we go back. That is, we need to look for it. So it is here. So once we are done with that, we save and run again. So ladies and gentlemen, this is the 3D plot that shows you the surface that is coming to represent the rate of penicillin inactivation, or the rate of formation of the inactive complex, or the rate of hydrolysis, the rate of formation of the hydrolyzed product. Because this penicillin is going to be hydrolyzed, and the compound that is going to be forming is going to be inactive penicillin, which does not react to any bacteria that is in the body, because the penicillin is antibiotic. So you can turn it around and see. So that is it. Thank you.